Hello students and welcome to this lecture. In this lecture, we are going to study about how to find out the square root of any complex number. Also, we are going to study about the nth roots of unity, what are their properties, and then we are going to study about the cube roots of unity. After all this, we are going to study about the geometry of complex numbers, what are the equations of circles, straight lines, and equations of some of the very important conics like parabola, ellipse, and hyperbola. We already know how to find out the square root of a real number. But what about a square root of a complex number? How to find out exactly the square root of a complex number? So that's something we are going to study now. Let us say that we have a complex number z which is equal to a plus iota b and we want to find its square root. Now, let us say that square root of a plus iota b, that is z, is equal to another complex number x plus iota y. So let us say that the square root of z is equal to another complex number which is x plus iota y. Now what we do next is we square both the sides, and what do we get? We get a plus iota b in the LHS, and in the RHS we get x square minus y square plus 2 iota into xy. So when we square both sides, this is the expression what we get. Now what we do is we equate the real and the imaginary parts. As these two complex numbers are equal, therefore their real parts must be equal and the imaginary parts must also be equal. So when we equate the real parts, we get a equal to x square minus y square, and similarly when we equate the imaginary parts, we get b equal to 2xy. Now we have to find out the values of x and y, and if we know the values of x and y, then we can find out the square root of z. We know that x square plus y square would be equal to under root of x square minus y square whole square plus 4x square y square. This is an algebraic identity. Now we know the value of x square minus y square which is equal to a, and also the value of 2xy is equal to b. Therefore, this would be equal to under root of a square plus b square. Thus the value of x square plus y square is equal to under root of a square plus b square. Now, x square would be equal to half of a plus under root of a square plus b square, and y square would be equal to half of under root of a square plus b square minus a. So we get the value of x square as this expression and the value of y square equal to this expression. Now we take the square root. Thus x would be equal to plus minus of under root of 1 by 2 into a plus under root of a square plus b square, and y would be equal to plus minus under root of 1 by 2 into under root of a square plus b square minus a. Thus we get two values of x and two values of y. Now which are these values? If b is greater than 0, that is b is positive, the imaginary part of the complex number z is positive, then xy should also be positive as b is equal to 2xy. Now if xy is positive, we have got two cases, either both x and y are positive and both x and y are negative, then only their product must be positive. So from this we can write the square root of a plus iota b would be equal to plus minus of under root of mod z plus a divided by 2, as we know that under root of a square plus b square is equal to mod z, plus iota times under root of mod z minus a divided by 2 if b is greater than 0. So if b is greater than 0 or the imaginary part of the complex number is greater than 0 or positive, then under root of a plus iota b or the square root of z would be equal to plus minus of under root of mod z plus a whole divided by 2 plus iota times under root of mod z minus a divided by 2 if b is greater than 0. And if b is less than 0 or b is negative, then we get under root of a plus iota b would be equal to plus minus of under root of mod z plus a divided by 2 minus iota times under root of mod z minus a divided by 2. So on the basis of sign of b, we get two values of the square root. So this is the procedure for finding the square root of any complex number. Now the next topic is the nth roots of unity, and it is one of the most important parts of complex numbers. Now let us say that we have an equation x to the power of n equal to 1. Now this is a polynomial equation of degree n, and we know that if we have a polynomial equation of degree n, then this equation must have n roots. So this very equation has got n roots. Now what are these roots? We can write x to the power of n equal to 1 as equal to cos of 0 plus iota times sine of 0. We can write 1 as cos of 0 degrees plus iota times sine of 0 degrees. Or x to the power of n is equal to cos of 2k pi plus iota times sine of 2k pi. We can write 1 in this form. 1 is also a complex number and we have written it in the polar form. Now x would be equal to cos of 2k pi plus iota times sine 2k pi to the power of 1 by n. We have taken nth root. And from the De Moivre's theorem, we get x equal to cos of 2k pi by n plus iota times sine of 2k pi by n. Now k is a variable whose values can be 0, 1, 2, 3 and so up to n minus 1. Thus we get n roots. X can have n values depending on the values of k. If we put different values of k, that is from 0 to n minus 1, we get n roots, and these are the roots of unity. So if we have an expression x to the power of n equal to 1, then the n roots of this polynomial equation are x equal to cos of 2k pi by n plus iota times sine of 2k pi by n, where k varies from 0 to n minus 1. Thus these are known as the nth roots of unity. Now if we take alpha equal to cos of 2 pi by n plus iota times sine of 2 pi by n, if we put k equal to 1 and let us say that this value obtained is equal to alpha, then the n roots would be 1, alpha, alpha square, alpha cube and so on up to alpha to the power of n minus 1. Thus if we take k to be equal to 1 and the root obtained to be equal to alpha, then the other n roots would be 1, alpha, alpha square, alpha cube and so on up to alpha to the power of n minus 1. Thus these are the n roots of unity, where alpha is equal to cos of 2 pi by n plus iota times sine of 2 pi by n. Now let's see some of the important properties of these nth roots of unity. The first is sum of n roots of unity is equal to 0. That is, if we add all these n roots of unity, then the sum is equal to 0. How? Let's see. The roots are 1, alpha, alpha square, alpha cube and so on up to alpha to the power of n minus 1. Now we clearly see that all these terms are in GP, and we've already studied how to find the sum of n terms of a GP. So sum would be equal to 1 plus alpha square plus alpha cube and so on up to alpha to the power of n minus 1. This would become 1 minus alpha to the power of n divided by 1 minus alpha. Here the common ratio is alpha. So the sum is this. Now alpha to the power of n would be cos of 2 pi plus iota times sine of 2 pi. Therefore we can write it as sum equal to 1 minus cos of 2 pi plus iota times sine of 2 pi whole divided by 1 minus alpha. Now cos of 2 pi is 1 and sine of 2 pi is equal to 0. Therefore this would be actually 1, and thus we get the sum as 1 minus 1 whole divided by 1 minus alpha. The numerator becomes 0 and so the sum would be equal to 0. Thus the sum of n roots of unity is always equal to 0. So if we add all the roots of unity, then the sum would be equal to 0. The second is product of nth roots of unity equals minus 1 for n being even and plus 1 for n being odd. So if we multiply all these roots, then their product would be equal to minus 1 if n is even, and their product would be equal to plus 1 if n is odd. That is, the product is equal to minus 1 to the power of n minus 1. If n is even, then we get the product equal to minus 1, and if n is odd, then we get the product as equal to plus 1. The third property is, on the complex plane, we can see that these roots lie on a unit circle equally separated by an angle of 2 pi by n. Thus, they can be thought of as vertices of a regular polygon. So let us say that we have the Argand plane in which this represents the real axis and this represents the imaginary axis. Now, let us say that we have a circle on this Argand plane with center at the origin and the radius of the circle is equal to 1. Therefore, this point would be equal to 1, this would be iota, this would be minus 1 and this would be minus iota. So, this is a unit circle with center at the origin. Now we see that this is one of the roots of unity. Similarly, the other root alpha 1 would be this one and the angle formed is theta with the real axis. Similarly, the second root would be alpha 2 and it would also lie on this circle, and this angle formed between these two roots is also equal to theta. Thus this angle would be 2 theta. And so on, we can say that all these roots would lie on the circle. This is a unit circle and this theta is actually equal to 2 pi by n. So this root would be alpha n minus 1 and also this angle would be equal to theta. So we can say that all these roots are equally spaced and they lie on this unit circle with center at the origin. Also, they are separated by an angle of 2 pi by n. Thus, if we join these points, we get a regular polygon. All these points are the vertices of a regular polygon and such that the angle between them is equal to 2 pi by n. Now, we have seen the nth roots of unity. Let's see the cube roots of unity. So we have an equation x cube equal to 1. Now this is a polynomial equation with degree equal to 3. So how many roots it would have? Definitely it would have 3 roots. But now what are these 3 roots? We can write x cube minus 1 equal to 0. We take 1 to this side and this equation becomes x cube minus 1 equal to 0. Now the expansion of x cube minus 1 would be x minus 1 into x square plus x plus 1 equal to 0. This is a linear expression and this is a quadratic expression. So this would give x equal to 1 as one of its root and we have to find the 2 roots. Now this is a quadratic equation with degree equal to 2. Therefore, this expression must have 2 roots. Thus, these 2 roots are minus 1 plus iota times root 3 divided by 2 and minus 1 minus iota times root 3 divided by 2. We know how to find the roots of a quadratic equation. In our chapter on quadratic equations, we have already studied about how to find the roots of a quadratic equation. So finally, we can say that the 3 roots of this equation are 1, minus 1 plus iota root 3 divided by 2 and minus 1 minus iota root 3 divided by 2. Now if we say that this is equal to omega, so if this root is equal to omega, then this root would actually be omega square. That is, if you square this root, you'll get omega square. That is, we can say that the cube roots of unity are 1, omega and omega square, where omega has a value equal to minus 1 plus iota root 3 divided by 2 and omega square has a value minus 1 minus iota root 3 divided by 2. Thus these are the 3 roots of unity. Now it's time for us to see some of the very important properties of the cube roots of unity. The first is 1 plus omega square is equal to 0. Why so? Because we have already seen that the sum of n roots of unity is always equal to 0. Therefore 1 plus omega square is always equal to 0. The second property is omega cube is equal to 1. When we multiply both these roots, we get the value equal to 1. The third is omega to the power of 3n is equal to 1. Omega to the power of 3n plus 1 is equal to omega, and omega to the power of 3n plus 2 is equal to omega square. This is because omega cube is equal to 1. The fourth property is conjugate of omega is equal to omega square, and the square of conjugate of omega is equal to omega. Thus the conjugate of omega comes out to be omega square, and the conjugate of omega square is equal to omega. Now, the cube roots of unity lie on the vertices of an equilateral triangle inscribed in a unit circle with center at origin. One of the vertex lies on the positive real axis. Now let us say that we have these two as the axis. This is the real axis and this is the imaginary axis, and this point of intersection is the origin. Now let us say that we have a circle with center at origin and radius equal to 1. So this is a unit circle with center at the origin. Now we have described an equilateral triangle, and the 3 roots, that is 1, omega and omega square, would lie on the vertices of this equilateral triangle, which is circumscribed by a unit circle with center at origin. Also one of its roots, that is 1, lies on the real axis. 1 is a positive real number, therefore this root lies on the real axis. This is omega and this is omega square, and these 3 are the cube roots of unity. and these three cube roots of unity lie on the vertices of an equilateral triangle which is inscribed in a unit circle with center at origin. One of its vertex, that is 1, lies on the positive real axis. So these were some of the important properties of the cube roots of unity. Now, based on them, let's try to solve a few examples. Evaluate the expression 1 plus 5 omega square plus omega to the power of 4 into 1 plus 5 omega plus omega square into 5 plus omega square, where omega is a complex cube root of unity. So in this problem, we have been given an expression that involves the cube roots of unity, and we have to find the value of this expression. So let's see the solution of this. The given expression is 1 plus 5 omega square plus omega to the power of 4 into 1 plus 5 omega plus omega square into 5 plus omega square. Now one by one we are going to see what is the value of these expressions. The first is 1 plus 5 omega square plus omega to the power of 4. Now omega to the power of 4 is equal to omega into omega cube, and also we know that omega cube is equal to 1. Therefore this would become omega. Thus this expression would reduce to 1 plus 5 omega square plus omega. Now also we know that 1 plus omega square is equal to 0. Therefore 1 plus omega would be minus omega square. So we substitute this value in this expression to get 5 omega square minus omega square, and this is equal to 4 omega square. Thus the value of this expression is 4 omega square. Let's look at the second expression, which is 1 plus 5 omega plus omega square. Now we know that 1 plus omega square would be equal to minus omega, and we substitute this value over here to get 5 omega minus omega, which is equal to 4 omega. Thus the value of this expression comes out to be 4 times omega. Now let's see the last expression, which is 5 plus omega square. Now omega square plus omega is equal to minus 1, and we substitute over here to get 5 minus 1 equal to 4. Thus the value of this expression is 4 omega square, value of this expression is 4 omega, and the value of this expression is 4. Thus the product would be 4 into 4 omega square. When we multiply, we get 64 omega cube, and we know that omega cube is equal to 1. Thus the final value becomes 64. Thus the value of the expression 1 plus 5 omega square plus omega to the power of 4 into 1 plus 5 omega plus omega square into 5 plus omega square is equal to 64. And so we have solved this problem. Let's try to solve an IIT problem, and this problem appeared in 1995. This problem says that if omega not equal to 1 is a cube root of unity, and 1 plus omega whole to the power of 7 is equal to a plus b omega, then a and b are respectively. We have been given the four options, which are a 0, 1, b is 1, 1, c is 1, 0, and d is minus 1, 1. So in this problem we have been given that omega is a cube root of unity, and we have been given an equation 1 plus omega whole to the power of 7 equal to a plus b omega, and we have to find out the values of a and b. So let's again try to solve this problem. Given to us is 1 plus omega whole to the power of 7 equal to a plus b omega. Now we can write 1 plus omega as equal to minus omega square, because 1 plus omega square is equal to 0. Thus minus omega square to the power of 7 equal to a plus b omega. Thus becomes minus omega to the power of 14 equal to a plus b omega. Now omega cube is equal to 1. Therefore omega to the power of 12 would also be equal to 1, and thus omega to the power of 14 would be omega square. Thus this becomes minus omega square equal to a plus b omega. Now we can write minus omega square as equal to 1 plus omega. Now we also know that minus omega square is equal to 1 plus omega. Thus 1 plus omega is equal to a plus b times omega. Now comparing both sides of the equation, what do we get? We get the value of a equal to 1 and the value of b also equal to 1. And so we can say that option number B is correct. Simply using the concepts of cube roots of unity, we solved this IIT problem.